Alright, we're going to try recording a video today to kind of pick up where we left off with electricity. So our last part of electricity is going to be on circuit analysis, basically analyzing the current, voltage, and resistance for series circuits, parallel circuits, and circuits that have both series and parallel combinations. So we're going to start by remembering a couple of rules. We learned Kirchhoff's Junction Rule, and we're going to also learn a little bit about the loop rule as well. So this is kind of a recap first with the junction rule. So the junction rule says a sum of all currents into a junction has to equal the sum of all currents out of a junction. So what does that mean? Well, if we look at a parallel circuit, so here we have a junction. So right here, current comes into this junction right here, and then it's going to divide. So some of the current will go this way, and some will go this way. Then our current reaches this junction. So here our current, these two different currents come together and have to exit. So we could write that in kind of an equation form. I'm going to call this I1, I'm going to call this I2, and this I3. I1 comes into the junction, so it has to equal I2 plus I3. Pretty simple. So if we know that current comes in, it has to also exit. So yeah, that one's super helpful when looking at parallel circuits. So if we look at a series circuit, by the way, remember the squiggles are just resistors. Whatever. These are just resistors. I can call them like R1, R2, R3 just to distinguish them. They're just whatever is kind of using the energy of the circuit, or whatever is kind of blocking the flow of current. So it could be a light bulb. A light bulb is a resistor. We usually draw a light bulb like this, but it could be whatever element is just restricting the flow of the current. The two lines here, this is our battery. So here in our series circuit, there are no junctions, so the current is the same everywhere in that circuit. So let's do the loop rule, and then we'll try analyzing a circuit. So Kirchhoff's loop rule basically tells us about how the voltage of a circuit is broken up. So let's look at a parallel circuit real quick. And I'll make it light bulbs this time. So Kirchhoff's loop rule basically says that the sum of all of the voltage drops in a circuit has to equal the total voltage provided by the batteries, or sometimes you'll see it written as the sum of all of the voltage drops minus the voltage of the battery equals 0. Basically, this is a conservation of energy. Remember that voltage is kind of our electric potential energy per charge. So this basically just says that we can't have more voltage than the battery is supplying. So what do I mean by a loop? Well, we can make a complete path all the way around the circuit here. Sorry, that was like a really thin marker. I'm going to go thicker there. So this right here is a complete loop because we can go through that light bulb without touching the other bulb. So this right here is also a loop. So this circuit has two loops, the inner loop with this first light bulb and the outer loop with this second light bulb. And what that tells us is if we were to measure the voltage of this first light bulb, we're going to call this 1, this is 2. The voltage of that first light bulb has to equal the battery's voltage because it's the only thing on the loop. The voltage of that second light bulb has to equal the voltage of the battery because it's the only thing on that loop. Now for a series circuit, let's draw ourselves a little series circuit here. There's only one loop here. So if we call these like a voltage 1, we measure the voltage just across that bulb. Voltage 2, the voltage just across that bulb. Voltage 3, this is the voltage of the battery. Well, there's only one loop here. So voltage 1 plus voltage 2 plus voltage 3 equals the voltage of the battery. Or they're each only getting a piece of that battery's voltage. So that is basic on the loop rule and junction rule. Next, we're going to take a look at using that in analyzing a circuit. Remember our two best friends analyzing circuit, Ohm's law, V equals IR, is going to be very helpful in conjunction with the two rules. And then we also have our equation for power. Power equals IV, also helpful when trying to analyze which bulbs or resistors use power or the brightness of them. So next we will take a look at analyzing some circuits.